Dear students, today we will continue with array concepts. We have already seen what the array is in the last class. Just I will give brief on the array and then I'll continue. As we know, array is set of values with one name. As you can see on the screen, A is one array name and A of 0 is first element, A of 1 is second element, A of 2 is third element, and then A of 3 is fourth element, and A of 4 is fifth element. And remember, always we will start array with A of 0, and this we will call it as a indice or maybe index or maybe subscript values. That means these are the subscripts. And you can see one advantage of this subscript. It starts from 0 and it lasts up to n minus 1. If n is 5, 5 minus 1. That is the concept of array. And advantage is just by using the name, the same name, by using one for statement, we can repeat the array values. That means we can take the array value, we can access the array value just by using array name and the for statement. That means by using for statement, we can repeat the indices or maybe the subscript. And in C++, when we are using array, okay, we use different types of arrays. There are different types of arrays, and the first one is one-dimensional array. If there is array name with only one side, then that is called one-dimensional array. Then the two-dimensional array name with two sides, maybe A of 10, 10. We can call it as a two-dimensional array. Multi-dimensional, if there is more than two dimensions, more than two sides for one array, we will call it as a multi-dimensional array. The first we will see one-dimensional array. It is an array in which each element is accessed by using only one subscript. Okay, and the only one subscript represents the position of the element in an array. And in the two-dimensional array, each element is accessed by using two subscripts. That means commonly we will say there will be a row and columns. Many number of rows and many number of columns. And then there will be like each element is accessed by using row number or row subscript and the column subscript. And in the multi-dimensional, it is an array of n dimension. That means more than 2, 3, 4, 5, we will call it as a multi-dimensional array. And how we can declare one-dimensional array? So one-dimensional array we can declare by taking data type and the array name size. As we can see in the example, int is the data type, reg number 10. And remember one thing, in one array we can store only one type of data. If it is int, we can store only integer. If it is float, we can store float. If it is character, we can store character type of values. That means by using array, we can store only one type of many number of values. Then how we can initialize? We can see a of 5 is equal to curly. Then we can take the values one by one. Then automatically it will take a of 0 as 9, a of 1 as minus 5, a of 2 as 6, a of 3 as 2, and a of 4 as 8. In this way, we can store 5 different values by using initialization method. That means in variable concept, we will take a is equal to 10. Then the 10 will be assigned to a. Same way, we can assign many values at a time by using this method. This is called initialization method. Okay, if you are taking float, then we can store float values in the array. If the array does not include an initialization, Then the array element may contain an unexpected values. We will call it as a garbage value. That means it will store any type of values. Okay, if we are not assigning one value to array. Then how we can access the element? As you can see, when we are declaring int a of I, then we can enter the elements in the array by using for statement. By using I equal to 0, I less than 5, I plus plus C in a of I. That means the subscript, as I said earlier, the subscript ranges from 0 to n minus 1. And that 0 to n minus 1 we can take by using for statement, and we can take values one by one in the array. Even we can print the same array values by using for statement. Like see out the elements are for I is equal to 0, I less than 5, I plus plus see out a of I backslash t. Then it will print all the values separately one by one, and the backslash t we have given to give the 5 space in between. Okay, now we will see programs to read the elements into the array and printing the elements. So how we can take? Maybe hash include IO stream, then void main int a of 50. Conio is not necessary since we are using Linux, that is NCC, NCC++. So there is no necessity of hash include conio.h. But if you are using Turbo C, we need conio.h. Then void main, then int a of 50. So we have taken the size as 50. The meaning is from a of 0 to a of 49, we can store different values. Then I to take the subscript values, and the n to take the number of values. So we can see out enter the size of the array, then C in n. C out enter the element by taking for I is equal to 0, I less than n, I plus plus C in a of I. That means we can take all the elements. Here you can see how they have shown in the output. Enter the size of the array, that is 5. That is nothing but n here. And when it is 5, then for statements repeats from I is equal to 0, I less than 5, I plus plus. That means C in a of I. So we have taken the values 10, 20, 30, 40, 50. Then the elements, we are printing those elements by taking C out a of I backslash t. Then it will print all the values which are in the array. How the memory representation is for the one-dimensional array. The elements of one-dimensional arrays are stored in continuous memory location. That is contiguous memory locations. Maybe if I take char a of 5, then it will store single character in one location. That means a of 0, there is one value, a of 1, one value, a of 2, one value. Okay, even it is represented as 1000, 1001. That means 1000 means one address, and one address can store one byte. 1001 again second. That means char means it will take 1 byte of memory. If it is int, it will take 2 bytes of memory. Float, 4 bytes of memory. So because of that, here it is taking 1000, 1001, 1002, 1003 and 1004. So in this way, a of 0, a of 1, a of 2, a of 3, a of 4. For example, if we are taking int a of 3, then 1000, 1001 is for a of 0. As I said, int means it needs 2 bytes of memory. Okay, 2 bytes of memory. So it takes 2 addresses. That is 1000 location stores 1 byte. 1001 is for 1 byte. That means the 2 bytes for the integer. From 1002, 1003, again a of 1. 1004, 1005, again a of 2. The amount of storage space required to hold an array is directly related to its data type and the size of the array. The total size can be calculated using the relation total size is equal to size of data type. For example, if it is int, then it may be 2 size of int. If it is character, it may be 1 into the size of array. That means into n. For example, if the n is 5, then if it is of type int, then 2 into 5. That means the memory needed is 10 bytes. If it is character, memory needed is 5 bytes. Okay? Then that way we can calculate the total size. If there is a question, memory representation of one-dimensional array, then you have to give the examples in this way, just by taking int, character or float. Next, to find the sum and average of n number of the array. The same type of method. Here you can see we are using a of 50, int a of 50, one maximum value. Since taking a of n is not possible for the array, it must be a constant. We have to take one constant as a size. So a of 50, I, n, sum. Then the float avg, CLR is see out how many elements. C in n elements. Then see out, enter the elements. In the same way, for I is equal to 0, I less than n, I plus plus C in a of I. Take all the values and take sum as 0. We have to take sum as 0 since it contains some garbage value. Okay, unwanted value. And to remove that one, we will take sum equal to 0 since we are using sum on the right hand side. Okay, RHS. For I is equal to 0, I less than n, I plus plus. Sum is equal to 0 plus first value. Again, it repeats. Sum is equal to sum plus second value. That is, first time it takes 0 plus 10. Second time it takes 10 plus 20. Third time it takes 30 plus 30. And the fourth time it takes 60 plus 40, maybe 100. Then 100 plus 50. Okay, 150. Then the sum, in sum there may be value 150. Then AVG is equal to sum divided by n. But we have used typecasting method because sum is of type int, even the n is of type int. To convert it to float type, sum divided by n, and we have used typecasting method. Then it will be converted to float type and the answer will be assigned to AVG. Then the average is equal to 30.00. Then see out, sum is equal to sum. It will display the sum and average is equal to AVG. To find the second largest of n number in the array. So presently, like how many elements? First you can take the n value. Then enter the element C in A of I. Till here it is same. Then if A of 0 greater than A of 1, A of 0 greater than A of 1, largest is equal to A of 0 and the second largest is A of 1. Okay. Else largest is equal to A of 1 and second largest is A of 0. For I is equal to 2, I less than n, I plus plus. That means here we have assigned the largest and second largest. We made the assumption. The first value in the array is largest and the second value in the array is second largest. If A of 0 greater than A of 1. By comparing the first value and second value, we made the assumption. So largest is A of 0, second largest is A of 1. Okay. And then otherwise, largest is equal to A of 1, second largest is A of 0. We made the assumption. Okay. Then first, comparing that first and second value is not necessary because already we have made the comparison. And from the second value, so comparing 0 and 1 is not necessary. From the third value, that is I is equal to 2, I less than n, I plus plus. If A of I greater than largest, second largest is equal to largest and largest is equal to A of I. Okay, That means we are taking the third value as largest and the second value as, if it is smaller than largest value, that we will take it as a second largest. So in this way, we will do the comparison. If a of I greater than second largest equal to a of I, okay, in that way we will do the comparison. By that we can print the largest and second largest. Okay, now the sorting process. Even we can arrange the numbers in ascending or in descending order. And for that, we can use the same array concept. Since array is to store set of values, and those set of values we can arrange in orders, maybe in ascending or in descending order. How? We will see now. Maybe we have taken int a of 50, that is array, and then we took I for the subscript, one temporary variable for exchanging purpose, then j, and then n. Okay. Then cout, enter the number of elements, c in n. Enter the elements I is equal to 0, I less than n, I plus plus c in a of I is equal to 1. That means the second element we will take it as a first element. And then j is equal to 0. That means the first element we are starting using j. That means using I we are taking the second element, and using j we are taking the first element. From j is equal to 0, I is equal to 1. If a of j, that means the first element, greater than a of j plus 1, that means the j plus 1 means the second element. Okay, that means the first element. If a of j greater than a of j plus 1, then we are exchanging. Okay, if a of j, that means the first element, is greater than second element, then we are exchanging. Okay, and the same concept we will continue till the elements are sorted. Okay, now see out the sorted elements are I is equal to 0, I less than n, I plus plus, then see out a of I. The same way we can do the searching process. Okay, the searching process. How we can do the searching process? We can search one element in the array. Maybe for example, when we are taking one element, if there are 10 values, maybe we will take another value as a search value, and that search value we can search in the array. Maybe we'll see example here. Maybe 10, 20, 30, 40, 50 are the array elements. Maybe we are searching 40. Then it will display 40 is present at position 3. 0, 1, 2, 3. So how we can do this process? Just we will see example. So C in n, that is enter number of element. C out, enter the elements by using for. We will take all the values. Then C out, enter the search element. That is C in element. Okay, it may present or may not. We will take one element. Then we will take position is equal to -1. Remember, -1 we are taking means it is equivalent to null. Position is equal to -1. Then I is equal to 0, I less than n, I plus plus. If element is equal to a of I, if the given element is equal to a of 0, then position is equal to I break. That means we came to know the element is at this position. Again, if it is not there, again it will go on and it will take first element. Then element is equal to a of 1, position is equal to 1. Again it repeats. If position greater than or equal to 0, element is present at position, then POS. Otherwise, C out, element is not present, enter. So in this way, we will continue. If position is -1 only, the meaning is the element is not present. If the position is other than -1, okay, then the meaning is position is having some value means the meaning is the element is in the array. Okay. For example, we will take these values and we will try to find out once again. So PO is equal to -1. I is equal to 0, I less than n, I plus plus. So first time it takes 10. Element, given element is 40. So 40 is equal to A of 0, 10, no. So then it will take the second one. That means I as 1. So 20. 20 is equal to this element, given element, 40 is equal to 20, no. Again it increments, I as 2, 30. So 30, that means 40 is equal to 30, no. Again it will take I as 3. Then it is 40. So 40 is equal to 40, yes. So position is equal to 3, then come out. Is position greater than or equal to 0? Yes, because position is 3. So then it prints element, that is 40, is present at position 3. Okay, this is the method. If, for example, if the element is 25, now 25 is not in this array. So it will take I is equal to 0. Then it will take first element 10. 25. So 25 is equal to 10? No. Then again it will take I as 1. 25 is equal to 20? No. Then I is equal to 2. 25 is equal to 30? No. I is equal to 3. 25 is equal to 40? No. Then again it takes I as 4. 25 is equal to 50? No. Now the POS is not changed. Still it is -1. So if POS is greater than or equal to 0? No. It is less than 0. So see out, 25 is not present. Okay, in this way we can search the element. Now two-dimensional array. How we can make use of this two-dimensional array? If there is a array with two sides, row number and the column number. So we can see row number is from 0 to m minus 1. If the m is the row limit, and column number 0 to n minus 1 if the n is the column limit, and the total number of elements may be m minus 1 into n minus 1. Maybe for example 0, 1, 2, 3. Okay, if there is a 3 into 3, that means 9 elements. If there is a of 2 is a row number, 3 is the column number, then 2 into 3. So then there will be 6 elements in the two-dimensional array. And each element is represented by row number and column number. Maybe for example, if it is A of 0, 0 is this element. A of 0, 1 is this element. A of 0, 2 is this element. Again, A of 1, 0 is this element. And A of 1, 1 is this element. And A of 1, 2 is this element. And then A of 2, 0, 2, 1, 2, 2. That means it will take row number and then it repeats the columns. Column values, column number. 0, 0, 0, 1, 0, 2. Then 1, 0, 1, 1, 1, 2. 2, 0, 2, 1, 2, 2. Like that way. Now how we can declare two-dimensional array? The same type of concept, but we will take the row size and the column size. That means the size 1 and size 2. Data type, array name, size 1 and the size 2. How we can initialize? Initialization is same type of method, but instead of single size, we will take two size. Maybe int a of 2, 3. That means 6 values we have to take. Then in the curly 1, 2, 3, 4, 5, 6, then semicolon. Okay. And two-dimensional array which contains 2 rows and 3 columns, these assignment would be A of 0, 0 is 1, A of 0, 1 is 2, A of 0, 2 is 3, and then A of 1, 0 is 4, A of 1, 1 is 5, and A of 1, 2 is 6. That means we are using two subscripts, row subscript and the column subscript to take each value in the two-dimensional array. 2 rows and 3 columns. Now, 0th row, 0th column, 0th row, first column, 0th row, second column, and first row, 0th column, and first row, first column, first row, second column. Like even we can take in this way, like B of 2, 3 is equal to in first row 1, 2, in the second row 3. Then in the first row it will take 1, 2, and here it will not take any values. And in the second row it will take 3, and here it will not take values. Then we can initialize the two-dimensional array with limited values. Okay, even if you are taking full values, to take the full values we can go for this method. But to take the limited values, we can go for this method. Then how we can access the two-dimensional array elements? To access this two-dimensional array, now there are two size, row size and column size. So we need two for statements. And as we know, when we are taking two for statement, inner for loop is repeated, outer for loop number of times. Inner for loop is repeated, outer for loop number of times. That means I is equal to 0, I less than 2, I plus plus. J is equal to 0, j less than 3, j plus plus. Then C in, it will take I as 0 and j as 0 first time. That means A of 0, 0. Second time, it will keep the I element as it is, since the inner for loop has to be completed. Then A of 0, 1, then A of 0, 2, and then again it will go back, it will take 1, again it starts j from 0, then 1, 0, 1, 1, 1, 2. Inner for loop is repeated first and then outer for loop. Even we can print in the same type of method, but we will use cout. So we will see one program, how we can use the two-dimensional array. Then int a of 5, 5. That means the row size, column size, both you have to specify. Then I is needed for row, j is needed for column. M is row size and the n is column size. Enter the order. C in mn. That means the row size and column size. Enter the elements. For I is equal to 0, I less than m, I plus plus. J is equal to 0, j less than n, j plus plus. C in A of ij. See out the array elements are for I is equal to 0, I less than m, I plus plus. J is equal to 0, j less than n, j plus plus. Then we can take cout A of ij and then cout endl. We can use backslash n. We can input the values and we can display those values on the basis of order. Write a program to sum up all the rows and sum up all the columns in matrices separately. Now here we can see we took all the values, okay, and we stored all the values in the array. Now we have to find out the row sum and the column sum. And I is equal to 0, I less than r, I plus plus. R sum is equal to 0, j is equal to 0, j less than c, j plus plus. So R sum is equal to R sum plus A of ij. That means row sum is equal to row sum plus A of ij. Then sum of row number I plus 1 R sum. The first row sum is printed. Again it will take the R sum is equal to 0. Then R sum is equal to R sum plus A of second row elements. That means that each time when it is going for first I is equal to 0, then the first row of elements will be taken. I is equal to 1, the second row of elements will be taken and it will display the sum. Okay, the same way C sum we can find out by changing the column number. Okay, column j we can take it as a first element and I as second element. Then a of ji. Here a of ij, that means a of 0, 0, 0, 1 and then 0, 2. But here a of j, that means the 0 is changing. Then automatically what happens, it will take the column values. So 0, 1, 0, 0 first time, second time 1, 0, second time, third time 2, 0. If there are 3 elements. Okay. If there are only 2, then it will take only here the j, that means the row index is changing, but the column will be kept constant. Write a program to find the sum of two matrices. We can find the sum of addition of two matrices by using the same type of method. A is first to take the first matrix value, B is to take the second matrix value, and this is to find the sum. That means the sum 5, 5. That means sum 5, 5 is equal to A 5, 5 plus B 5, 5 in that way. So for the first matrix, we have taken R1, C1 and second matrix R2, C2. Then Ij. You can see, enter the order of first matrix. So the order of first matrix in R1, C1. Enter the order of second matrix, that is R2, C2. Then we can store the elements. I is equal to 0, I less than R1, I plus plus. J is equal to 0, J less than C1, J plus plus. C in A of ij. Here it is not R, it is R1 and here it is C1. In the same way, we can take the second matrix. I is equal to 0, I less than R2, I plus plus. J is equal to 0, J less than C2, J plus plus. So we took the second matrix values. Now all the elements of matrices in the memory. Then we can take, if R1 is equal to R2 and C1 is equal to C2, to add the row of first matrix and the row of second matrix must be same, and the column of first matrix must be equal to column of second matrix. Okay, so for that purpose, we can see here the first row matrix, maybe for example 0, 1, 2 is the first value, then 3, 4 and the 5. Now here there are 2 rows, okay, and 3 columns. Now when we are taking the second matrix, it must be of the same size. That means if there are 2 rows in the first matrix, even in the second matrix there must be 2 rows and 3 columns. If you are taking 3 rows, 3 columns, second matrix must be of 3 rows, 3 columns. That we are checking here, and then we are continuing. Like I is equal to 0, I less than R, I plus plus. J is equal to 0, J less than C, J plus plus. Then sum of Ij, that means sum of 0, 0 is equal to A of 0, 0 plus B of 0, 0. That means the first element of A and the second element of B, first element of B, we are assigning it to the first element of sum. By that we can add 2 matrices. So then matrix addition is over. Then at the end we can display that sum. We can display the sum matrix by taking same I is equal to 0, I less than R1, I plus plus, J is equal to 0, J less than C1, J plus plus, C out sum of Ij. See, then we can display the matrix. Otherwise, we can display matrices are not compatible when if the R1 not equal to R2 and C1 not equal to C2. Okay, so in this way we can do the two-dimensional array concept. So when you are coming to college, even you can find out by working in lab. Just note down these problems, all the problems, and just analyze it. Okay, and afterwards, when you'll come back to college, you can work on. Thank you. God bless you.